Hey, space lovers! Welcome to our channel, where we dive into the most mind-bending mysteries of the universe. Today, we're going to take you to a place that's so terrifying, so extreme, that even the most daring astronauts would never want to visit. We're talking about the most terrible place in the universe, a place where the laws of physics break down, where time and space twist in unimaginable ways, and where even light can't escape. Stick around, because you won't believe what's lurking out there in the dark. Before we get into this terrifying place, let's first define what we mean by terrible. Space itself is already a harsh and unforgiving environment. There's no air, no water, and temperatures can swing from freezing cold to blistering hot. But some places in the universe go beyond these extremes. These are the spots where gravity crushes anything in its path, where radiation levels would fry you instantly, or where time itself might slow down or speed up. In other words, these places challenge everything we know about survival and existence. But what if I told you there's a place even worse than that? The most terrible place in the universe? It has to be near a supermassive black hole. These cosmic monsters are millions or even billions of times the mass of our sun. They lurk at the centers of galaxies, including our own Milky Way. What makes a black hole so terrifying? Its gravity is so intense that once you get close enough, called the event horizon, not even light can escape. But it doesn't stop there. The area around a supermassive black hole is a swirling, chaotic mess of high-energy radiation, gas, and even entire stars being torn apart. Get too close, and you're in for a ride that no one, not even the best scientists, fully understands. One of the most horrifying things about getting too close to a black hole is something called spaghettification. Yep, you heard that right. As you approach a black hole, the difference in gravitational pull between your head and your feet becomes so extreme that it stretches you out like a piece of spaghetti. Eventually, you would be ripped apart atom by atom. This happens because black holes create what's called a gravitational gradient, which becomes stronger the closer you get. For anyone or anything unlucky enough to cross this point, it's a one-way trip to oblivion. As if spaghettification weren't terrifying enough, black holes also mess with time itself. This phenomenon is known as time dilation. The closer you get to the event horizon of a black hole, the slower time passes for you, at least compared to someone far away. In theory, if you were to watch someone fall into a black hole, they would appear to slow down and freeze just before they hit the event horizon. But from their perspective, time would seem to move normally until, of course, they were stretched into oblivion. This means that black holes don't just mess with space, they mess with time too. So what's next for black hole research? Scientists are trying to unlock more of the secrets hidden in these cosmic nightmares. The Event Horizon Telescope has already captured the first ever image of a black hole, giving us a glimpse of what these mysterious objects look like. But there's so much more to learn. Some physicists believe that black holes could even be portals to other dimensions or universes. Others think that studying black holes might help us finally figure out how gravity works on the smallest scales, which could revolutionize our understanding of physics. One thing's for sure, black holes are not just terrifying, they're also some of the most fascinating objects in the universe. Quasars are among the brightest and most powerful objects in the universe, powered by supermassive black holes at the centers of galaxies. These cosmic engines shine so brightly that they can outshine entire galaxies. But don't be fooled by their glow. Quasars are as deadly as they are beautiful. The intense radiation emitted by a quasar could sterilize any nearby planets, rendering them completely uninhabitable. If Earth were near a quasar, life would stand no chance. Luckily, quasars are far away from us, but their existence is a stark reminder of the violent power that exists in the cosmos. Imagine compressing the mass of the sun into a city-sized object. That's what happens with neutron stars, the incredibly dense remnants of supernova explosions. A single teaspoon of neutron star material would weigh billions of tons. Their gravity is so strong that if you got close, you'd be crushed in an instant. But that's not all. Some neutron stars spin rapidly, emitting beams of radiation that sweep across the sky like cosmic lighthouses. These spinning stars, known as pulsars, emit pulses of deadly radiation, making them some of the most hostile environments imaginable. Not all planets orbit stars. Some, known as rogue planets, have been ejected from their home solar systems and now drift aimlessly through the cold, dark void of interstellar space. These planets are cut off from the warmth of a star, making them frozen, lifeless worlds. If you were to find yourself on a rogue planet, you'd be alone in the most desolate place imaginable, with no sun to guide you and no light to see. The eerie thought of planets wandering through the galaxy adds to the chilling nature of the universe. If you thought black holes were the most terrifying objects in the universe, wait until you hear about gamma-ray bursts. These are the most powerful explosions known, releasing more energy in a few seconds than the sun will emit in its entire lifetime. A gamma-ray burst could vaporize everything in its path. Luckily, they're rare and far away, but if one were to occur near Earth, the intense radiation would strip away our atmosphere and cause mass extinction. These cosmic death rays remind us just how fragile life is in the grand scheme of things. While some places in the universe are unimaginably hot, others are shockingly cold. In fact, the coldest known spot in the universe is the Boomerang Nebula, where temperatures drop to just 1 degree above absolute zero. At these temperatures, molecules barely move, and life as we know it would be impossible. This freezing environment is a stark contrast to the blazing heat of stars and black holes, showing just how extreme the universe can be. One of the most perplexing mysteries in astronomy is dark matter. We know it exists because we can see its gravitational effects, but we can't see it directly. Dark matter makes up about 85% of the matter in the universe, yet we have no idea what it is made of. It's a mysterious, invisible substance that shapes galaxies and influences the structure of the universe. Its elusive nature makes it all the more terrifying. It's everywhere, but we have no way to detect it. When massive stars reach the end of their lives, they explode in spectacular fashion, creating a supernova. These explosions are so powerful that they briefly outshine entire galaxies. The blast waves from supernovae can trigger the formation of new stars, but can also wipe out any nearby planets with their intense radiation. Supernovae are both the creators and destroyers of the universe, giving life to new worlds while obliterating others in an instant. The universe is so vast that there's a limit to how far we can see, known as the observable universe. Beyond this point, light from distant objects hasn't had enough time to reach us, meaning we can never know what lies beyond. The edge of the observable universe is about 46 billion light-years away, and what lies beyond is a complete mystery. The thought that we may never be able to explore these distant regions adds an unsettling layer to the vastness of space. The cosmic microwave background, CMB, is the faint afterglow of the Big Bang, the explosion that created the universe. It's a snapshot of the universe when it was just 380,000 years old. This radiation is all around us, providing evidence of the universe's violent birth. The CMB is like a cosmic fossil, a reminder of the universe's fiery origins. It's a humbling thought to realize that the peaceful night sky we see today was once filled with unimaginable chaos. Sometimes, two black holes can collide and merge, creating an even larger black hole. These events release massive amounts of energy in the form of gravitational waves, ripples in the fabric of space-time that we can now detect on Earth. When black holes merge, they create some of the most violent and energetic events in the universe. The idea of two invisible giants colliding in the darkness of space is as awe-inspiring as it is terrifying. The universe is vast, with billions of stars and planets, yet we haven't found any signs of intelligent life. This is the essence of the Fermi Paradox. If the universe is teeming with planets, why haven't we detected any alien civilizations? Could it be that advanced civilizations inevitably destroy themselves, Or are we simply alone in the cosmos? The silence of the universe is as eerie as it is mysterious, and it makes us wonder about our place in the grand scheme of things. The universe isn't static, it's expanding. In fact, it's expanding at an accelerating rate due to a mysterious force called dark energy. This means that galaxies are moving away from us, and one day, distant galaxies will be so far away that we won't be able to see them anymore. The universe will become a lonely, dark place, with only the remnants of our own galaxy visible. The thought of the universe drifting apart, leading to its eventual heat death, is a chilling reminder of the impermanence of all things. Our galaxy, along with many others in our local cluster, is being pulled towards something massive and mysterious called the Great Attractor. This gravitational anomaly is located about 150 million light-years away, and its exact nature is still unknown. Some scientists think it could be a massive collection of galaxies, while others suggest it's something even more exotic. Whatever it is, it's pulling entire galaxy clusters toward it, making it one of the universe's most enigmatic forces. The dark forest theory offers a chilling explanation for why we haven't encountered any alien civilizations. It suggests that the universe is like a dark forest, where civilizations hide to avoid being detected by others. In this theory, any civilization that reveals itself risks being destroyed by a more advanced one. The idea that the universe is full of silent, hiding civilizations, all fearing annihilation, is as unsettling as it is thought-provoking. Not every part of the universe is filled with galaxies and stars. There are vast, empty spaces known as voids, where very little matter exists. These regions are some of the loneliest places in the universe, stretching across hundreds of millions of light-years. If you were to find yourself in a void, you'd be completely isolated from any other stars or galaxies, surrounded by nothingness. The sheer emptiness of these cosmic deserts is a reminder of the vastness and isolation that pervades much of the universe. Cosmic rays are high-energy particles that travel through space at nearly the speed of light. They originate from various sources, including supernovae, black holes, and even distant galaxies. When these particles collide with the Earth's atmosphere, they can produce showers of secondary particles that can be harmful to life. The sheer energy of cosmic rays poses a threat to astronauts in space, as even small doses can lead to serious health issues. The thought of these invisible high-energy particles constantly bombarding us adds another layer of danger to our existence. While black holes consume everything in their vicinity, white holes are theoretical objects that do the opposite. They expel matter and energy. In theory, a white hole could be a portal to another universe, releasing energy and matter in a way that defies the laws of physics as we know them. However, white holes have never been observed, and their existence remains purely speculative. The idea that there could be cosmic phenomena that defy our understanding of gravity and time is both fascinating and terrifying. What if our universe is just one of many? The multiverse theory proposes that there are potentially infinite universes, each with its own laws of physics and conditions for life. Some of these universes could be incredibly hostile, with conditions that make life impossible. The idea that there might be universes where our existence is just a fleeting chance adds a layer of existential dread. If there are countless realities, what does that mean for our significance in the grand scheme of the cosmos? Strange matter is a hypothetical form of matter that could exist in the core of neutron stars. If a neutron star were to collide with another neutron star, it could create a strange star made entirely of strange matter. The gravitational pull of a strange star could be so strong that if it came into contact with regular matter, it could convert it into strange matter as well. This would lead to a catastrophic chain reaction, essentially turning anything it touches into a form of matter that could not support life. The thought of such a materializing object adds another layer of terror to our understanding of the cosmos. The Great Filter is a theory that tries to explain the apparent absence of extraterrestrial civilizations in the universe. It suggests that at some point in the evolution of life, there is a significant barrier that prevents civilizations from advancing to a point where they can communicate or travel through space. This barrier could be behind us, meaning that intelligent life is extremely rare, or it could be ahead of us, implying that we are doomed to fail before we reach the stars. The uncertainty surrounding our future adds an unsettling tension to our quest for extraterrestrial life. The Hubble Deep Field is an iconic image capturing a tiny patch of the sky filled with thousands of galaxies. This astonishing photograph reveals that the universe is far more crowded than we ever imagined. Each point of light represents an entire galaxy, teeming with stars and potentially even life. The vastness of space, filled with innumerable galaxies, serves as a humbling reminder of how small we are in the grand tapestry of the cosmos. The thought of countless worlds, some perhaps harboring life, highlights the mysterious nature of our existence. While the universe itself may be infinite, the observable universe is finite, limited by the speed of light and the age of the universe. This means there are parts of the universe that we will never be able to see or understand. The boundaries of our observable universe stretch approximately 46 billion light-years, but what lies beyond remains a complete mystery. The finite nature of our understanding is a humbling realization that there are cosmic truths we may never uncover. The universe is structured like a vast web, known as the cosmic web, consisting of clusters, filaments, and voids. This structure is formed by the gravitational pull of dark matter, which acts like an invisible glue holding galaxies together. The cosmic web illustrates how interconnected galaxies are, forming a delicate balance between attraction and repulsion in the vast expanse of space. The complexity of this structure and its dependence on unseen forces serve as a reminder of the intricate balance that governs the universe. Scientists have proposed several theories about how the universe will ultimately end. One of the most popular is the Big Freeze, where the universe continues to expand until stars burn out, leaving behind a cold, dark cosmos. Another possibility is the Big Crunch, where the universe's expansion eventually reverses, causing everything to collapse into a singularity. Lastly, there's the heat death, where entropy reaches a maximum and the universe becomes a state of uniform temperature. Each scenario presents a chilling vision of the universe's fate, emphasizing the transient nature of existence. The Orion Spur is a region of the Milky Way that contains several missing stars. It has been dubbed the Bermuda Triangle of space because of the peculiar absence of celestial bodies that should exist based on our models. Some scientists speculate that these stars may have been consumed by black holes, or that they could have collided with other cosmic objects. The enigma surrounding the Orion Spur serves as a reminder of how much we still have to learn about our galaxy and the mysteries that lie within. Cosmic inflation refers to a theory that suggests the universe underwent an exponential expansion just moments after the Big Bang. During this period, the universe grew from subatomic sizes to larger than galaxies in a fraction of a second. This rapid expansion explains the uniformity we see in the universe today, but also raises questions about the nature of space itself. The idea of the universe stretching and warping at unimaginable speeds is a mind-bending concept that adds to the surreal nature of cosmic history. Tidal forces are the result of gravitational pull from celestial bodies, creating intense stresses on nearby objects. For instance, the moon's gravity causes tides on Earth, but imagine the tidal forces near a black hole. If you were to approach a black hole, these forces could rip apart a spacecraft or even a planet. The destructive potential of tidal forces serves as a reminder of how gravity shapes the universe and how it can create catastrophic consequences. The cosmic calendar is a way to visualize the history of the universe compressed into 1 year. In this model, the Big Bang occurs on January 1 St, and all of human history occupies the last few seconds of December 31 St. This perspective highlights just how brief our existence is compared to the vast age of the universe. The notion that humanity is a mere blink in cosmic history brings a humbling sense of perspective and urgency to our quest for understanding. Magnetars are a type of neutron star with an incredibly strong magnetic field, potentially a trillion times stronger than that of Earth. This intense magnetic field can cause catastrophic bursts of gamma rays and X-rays. If a magnetar were to come close to Earth, it could disrupt electronic devices, cause radiation storms, and endanger life. The danger posed by these exotic objects illustrates the violent and chaotic nature of the cosmos. The void of Eridanus is one of the largest known voids in the universe, stretching hundreds of millions of light-years with very few galaxies. It serves as a stark reminder of the emptiness that can exist in the cosmos. The sheer size of this void creates a gravitational pull that influences surrounding galaxies, demonstrating how interconnected everything in the universe truly is. The existence of such vast emptiness can be quite disheartening, highlighting the isolation that can exist in space. Antimatter is the mirror image of regular matter, with particles that have opposite charges. When matter and antimatter meet, they annihilate each other, releasing vast amounts of energy. The universe contains very little antimatter compared to matter, raising questions about why this imbalance exists. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.